Here is the movie for pages 61 through 76, numbers 10 through 18. Number 10 says the function f is given by f of x equals ax squared plus 12 over x squared plus b. It says if the figure above shows the portion of the graph of f, which of the following could be the values of the constants a and b. This is more of a pre-calc question. This is really about asymptotes. We did do this at the beginning of the year, but it really does draw back to pre-calc a little more. If you take a look, we have an asymptote at x equals 2. And vertical asymptotes, let me just shrink this down a little bit. Vertical asymptotes are really important in terms of saying, well, a vertical asymptote happens when the denominator of a rational function ends up equaling 0. So if you think about what happens here, that means x squared plus b has to equal 0 when x is 2. So if you solve this for b, we get b is -4, which is kind of nice because it happens to be, it gives you the answer right off the bat. Now, if you're thinking about a is 3, horizontal asymptotes is about, you have to kind of think of, in terms of horizontal asymptotes, if you think for a minute, sorry, this should be an A. Horizontal asymptotes are about the battle going on between the numerator and denominator, because it's all about the limit as x goes to infinity or negative infinity. Either way, you kind of have to consider both. But for a rational function, they happen to be the same. So if you think about this, as x is getting big, the value of the function is tending to 3. So we know this limit is equal to 3. As x gets big, the x squared terms are the only ones that matter. These don't even really matter. So if you think about what has to happen here, this ratio has to equal 3. So you know a divided by 1 has to be 3, so a is 3. So that justifies our a being 3 as well, which is choice D. All right, number 11 says, what is the slope of the line? What is the slope of the line tangent to the graph of y equals e to the negative x over x plus 1 at x equals 1? So slope of the line tangent requires us to get the derivative. And this, it requires, it's a quotient, so it requires the quotient rule. So I have my high, which is e to the negative x, the low, which is x plus 1, high prime, and low prime we need to find. Low prime is easy, that's just 1. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. The derivative of negative x is -1. So we have negative e to the negative x being the high prime. So my formula for the quotient rule is low d high. Low is x plus 1 times d high, which is times negative e to the negative x, minus high d low, which is e to the negative x times 1, which is just minus e to the negative x, over low squared, which is x plus 1 squared. We want to evaluate the derivative at x equals 1. So we have to plug in 1 wherever we see x. So we get 1 plus 1 times negative e to the negative 1 minus e to the negative 1 over 1 plus 1 squared. So we get negative 2 e to the negative 1 minus e to the negative 1 over 2 squared, which is 4. Negative 2 e to the negative 1 minus 1 e to the negative 1. Those are like terms, so that simplifies to negative 3 e to the negative 1 over 4. E to the negative 1, to make it look like the answer choices, is 1 over e. So this becomes negative 3 over 4e, which is choice B. Number 12 says if f prime of x is 2 over x and f of square root of e is 5, then f of e equals. They gave us the derivative, and they would like us to find the original function at a certain value. So I would like to take the antiderivative of the derivative, which will give us back to the original function. If you're thinking power rule here, you run into this problem. If you try to add 1 to the power, because we're taking the antiderivative, so we add 1 to the power and divide by the power, the new power rather, we'll get a 0 in the denominator. So this is no good. So we're going to have we have our ln rule to help us here. So this is really ln, or sorry, 2 ln of absolute value of x plus c. So f of x is 2 ln of absolute value of x plus c. Now we want to find f of e, but they told us f of square root of e was 5. That will help us find the constant. So f of square root of e equals 2 ln of absolute value of square root of e plus c, and this has to equal 5. Well, first of all, square root of e is a positive number, so the absolute value bars don't matter. Oops, square root does, though. ln says what power of e gives you the square root of e? So what power of e is the square root of e? And the answer is, well, square root means the 1/2 power. So the ln of the square root of e is just 1/2. 2 times 1/2 is 1. So c is 4. So now I know the function is really this. F of x is really 2 ln of absolute value of x plus 4. And they want us to find f of e. So f of e is 2 ln of absolute value of e plus 4. ln of e, absolute value doesn't matter because e is already positive. What power of e gives you e? That's 1 plus 4. 2 plus 4 is 6. Choice D is the answer. Number 13, it says the integral of x cubed plus 1 squared. Some of you might think this is a u substitution problem. So I'll start it off as such. U, say you want to let u be x cubed plus 1. Du over dx equals 3x squared. If you think of a little further into here, there's no 3x squared or any x squared term living in this integrand. This is a bad way to do this problem. It is not a u substitution. It's not a problem for you. What it is, however, is a simple algebraic manipulation before you integrate. So I have x cubed plus 1 squared, which is really x cubed plus 1 times x cubed plus 1, which is easy enough for us to do. So if you distribute here, or FOIL, you get x to the 6th plus x cubed plus x cubed plus 1 dx. So this is the integral of x to the 6th plus 2x cubed plus 1 dx. And this becomes, we're doing the anti-power rule. So we're adding 1 to the power and dividing by the new power. Adding 1 to the power and dividing by the new power. The power on the 1 is x to the 0, so we're just going to add 1 and divide by 1. So it's just x plus a constant. 2 over 4 simplifies to 1 over 2. And this answer would match up with, you can write x to the 7 over 7 as 1/7 x to the 7. So choice B would be our answer. All right, 14. The limit as h goes to 0 of e to the 2 plus h minus e to the 2nd over h. We did a lot of these problems at the beginning of the year. We haven't done them in a while. If you remember, this is the definition of the derivative. So a limit written in this form is a derivative. So what we have to ask ourselves is, what is the function being differentiated here? The function is easiest gotten by this term. As you can see, the x plus h is being replaced by 2 plus h. So the function, okay, is just e to the x. So think about it. If f of x is e to the x, right? F of x plus h would be e to the x plus h. Instead, if I have f of 2 plus h, that's e to the 2 plus h. So that's why this gives us the clue as to what the function is. Make the long story short, the something plus h, if you replace it with x, is the function that this is the derivative of. So f of x is e to the x. F prime of x is also e to the x. Okay? So this thing is the derivative. Sorry, this thing is e to the x evaluated at what x value? Well, instead of having an x, we have a 2. So we want f prime of 2, which is e to the 2nd, which is choice D. And we did a lot of these problems way back at the beginning of the course. All right, 15 is a little trickier. And it's kind of one of those questions where you kind of have to just eliminate choices, because you may or may not know these graphs off the top of your head. It says the slope field for a certain differential equation is shown above. Which of the following could be the solution to the differential equation with the initial condition y of 0 equals 1? Well, y of 0 equals 1 is a point. It's the point 0, 1. The solution is the curve that's traced out by the slope field. And we saw this with the circles when we did the circle, when we did the differential equation for the circle. So if we look, our slopes, you kind of think of these as swimming lanes, are tracing out a curve that's making us do this. Something like this. On the other side, it's symmetric. Okay? So there is a rough sketch of what would be the solution curve. Now we have to ask ourselves what this looks like. The first choice is y equals cosine of x. Y equals cosine of x, it starts nice, but then remember, cosine dips below the x-axis and comes back up and stuff. That's not what's happening. If you look at these slopes down here, they're never ready to come turn back around. So this is not cosine, because this graph sloughs off and never hits the x-axis because of the way the slope field is going. 1 minus x squared is an upside down parabola. Okay, you should know x squared is a smiley face parabola, negative x squared is an upside down one, and then 1 shifts up 1. So that looks like that, not our solution curve. E to the x is an exponential. It looks like this, not our solution curve. Now you're down to D and E. D and E, okay? If you think about y equals square root of 1 minus x squared, okay? There's a few ways you can reason this out. One, you may notice that this is actually the equation of a circle. For example, if you square both sides here, you get y squared equals 1 minus x squared. Add over the x squared term, and this is x squared plus y squared equals 1. This is actually the top portion of a circle with radius 1. So the solution would stop at 1, but clearly our solution does not stop, and it's not a circle. Another way to think about it is the domain. Just as we said, if you tried plugging in a 2, 2 squared is 4, 1 minus 4 is the square root, it's negative 3, so we end up with the square root of negative 3. Square root of a negative is not a real number, so past 1, we wouldn't have a graph. So this is no good either. This is the answer. The graph of 1 over 1 plus x squared looks like this, and actually from statistics, this is sort of kind of like the normal curve, and that's what this graph actually looks like. All right. Number 16. If f prime of x equals absolute value of x minus 2, which could be the graph of f of x? Well, one way to think about this is here is f prime, and you are trying to match it up to f. F prime of x is absolute value of x minus 2. F prime tells us whether f is increasing or decreasing. If we try to set up a number line for this, we would set the derivative equal to 0. Well, if the absolute value of x minus 2 is 0, that means x minus 2 is equal to 0 and x is 2. So if we were to set up a number line for this, we'd have 2 on our number line for the derivative. And if we pick the point to the left of 2, say 1, absolute value of 1 minus 2 is absolute value of negative 1, which is 1, positive. And the absolute value, say past 2, which is 3, 3 minus 2 is positive 1, absolute value of positive 1 is 1. This derivative is positive except that 2. So what that tells you, this is a graph of f, this is the number line for f prime, f is increasing and then increasing again. Well, there's only one graph on here that does that, and that's choice E. The rest of these have decreasing portions. The other thing is, remember, this is given f prime. This is the graph of absolute value of x minus 2. But I'm asking you if f prime is this, what's the graph of regular f? I'm not asking you what the graph of f prime is, so please understand that there's some calculus involved. All right, number 17, it says, what is the area of the region enclosed by the graphs of f of x equals x minus 2x squared and g of x is negative 5x? And we did a lot of these types of problems. So f of x is x minus 2x squared. We have to think about what that looks like. The highest degree term is an x squared, so this is a parabola. It's a parabola that's upside down. And something that might be nice to see about it just for a minute is kind of where it hits the x-axis, so you can get a good picture of this thing in your head. So if I factor out the x, I would get 1 minus 2x is equal to 0. X equals 0. 1 minus 2x equals 0. So negative 2x is negative 1. X is a half. So this is a parabola that's upside down, and it has roots at 0 and a half. So here's a rough sketch of my parabola. And there's other ways to sketch this, and if you kind of understand what's going on, this isn't such a big deal in terms of the sketch being perfect. Now, negative 5x is a line. It starts at the origin as a y-intercept and goes down 5 over 1. So it's going to look something like this. Okay? And so we're going to get a region in here that we need to find the area of. So we need to get the intersection points of this graph because we need to form an integral. So actually, let's form the integral first. The integral from clearly 0 is one of the intersection points to the other intersection point of the top function minus the bottom. And that's why you need to get some semblance of an accurate picture here. The top function is the parabola. That's x minus 2x squared minus the bottom function, which is negative 5x. Now, we do need to find that other intersection point because we need the upper limit of the integral. So to find the intersection point, I'll set the two graphs equal to each other. And since this is a quadratic, we need to move all the terms to one side. So we can do it. There's a few ways you could do this. Here's one way. 6x minus 2x squared is 0. Factoring out a 2x, I'd be left with 3. Minus x equals 0. And from here we can see x equals 0 is a solution. 3 minus x being 0 means x is 3. So we have the integral from 0 to 3. And we have to do this by hand because it's a non-calculator question. I would simplify the integrand first. When you subtract a negative 5x, this becomes a positive 5x. We get x plus 5x, which is 6x, minus 2x squared dx. And this becomes, the integral of 6x becomes 6x squared over 2, minus the integral of 2x squared, which is 2x cubed over 3. This is evaluated from 0 to 3. 6 divided by 2 is 3, so this is 3x squared minus 2x cubed over 3, evaluated from 0 to 3. So we get 3 times 3 squared minus 2 times 3 cubed over 3, minus, technically I have to plug in 0 in for x, but these are just polynomials, so those terms just vanish. You get a 0 here. And so now we just have to figure out the arithmetic here. 3 squared is 9 times 3 is 27. 3 squared cubed is 27, divided by 3 is 9, and 9 times 2 is 18, so 27 minus 18 gives us 9, which is choice D. And one more. Whoops. I just want to make this a little bigger. Giving me a little trouble on the smartboard here. Whoops. Okay. Number 18 says for the function f prime of x is 2x plus 1, and f of 1 is 4. It says, what is the approximation of f of 1.2 found by using the line tangent to the graph at x equals 1? They're asking for a tangent line approximation. The first thing you need to do is find the equation of the tangent line. So what is the equation of the tangent line? Well, we always want to start out with y minus y1 equals m times x minus x1. So y minus y1, well, they gave us this point. F of 1 is 4. So f of 1 being 4, they gave us the x value and they gave us the y value, which is nice. So the y value is 4. We have to figure out the slope. And our x value is 1. The slope is gotten by the derivative. Your derivative is your slope. So f prime of x is the derivative. That's going to give us the slope. We just have to plug in the number 1 to get it. And 2 times 1 is 2 plus 1 is 3. So here's our tangent line. I'm going to solve this for y. I'll distribute, add the 4 to both sides. And so here's our tangent line, which, as we discussed, is an approximation of the function. So now we want to find f of 1.2. Well, f of 1.2 means find the y when x is 1.2. So I'll do that. Y equals 3 times 1.2 plus 1. 3 times 1.2 is, 3 times 1.2 would be 3.6 plus 1 equals 4.6. This would be our approximation to f of 1.2 using the tangent line. So 4.6 is the answer. So I just did those 9 questions in 20 minutes. I'm also explaining things as I go along, so that seems a reasonable pace to go at.